Okay, today we're going to talk about gravity. So gravity is a force. It's a non-contact force. The closer an object is to a larger mass, the greater gravitational force it will feel. Okay, so here's a picture that you guys are all going to be fascinated with. So what I want you guys to see from this picture is that the Earth has a gravitational field, and the vectors, the closer the vectors are to each other, the greater the gravitational force will be. And the farther away, the less. And so to conceptualize this, we say that Earth has a gravitational field. So, yes, I'm just going to have a gravitational field. So to do the fun part, the equations. So we're going to manipulate equations today. First, we're going to take Newton's gravitational law. The force of gravity equals big G over the mass of one object to the mass of the other object over r squared, which is radius squared. Second, we're going to take Newton's second law, which is pretty much, I'm just adding that we also know that the mass times surface gravity, which also surface gravity, then you know, is the gravitational field strength, which is what I was explaining to you earlier. So what we're going to do is we're going to make mass 1 the test object and mass 2 the larger object. So we're also down here, see where I put like m2 is times the surface gravity. So then we just take, we can take m2 out, we can cross it out. And so we just get that g times m1, which is the test object, divided by the radius squared equals g, which is pretty much the thing that you need to know, surface gravity and also gravitational field strength. These are the same things, okay? Surface gravity, gravitational field strength, and acceleration due to gravity are all the same. Okay, so here's another equation to get the same thing, which is g over force of gravity, which is, mg and all those other weird equations, over the m of the test, which is m1, also gives you g. So then also, just so you guys know, the different units, which we already know from previous things, that g is meters over seconds squared. Then also, it's also newtons over seconds, and there's some way to derive it, but we don't care. And that's all you need to know today, so I hope you guys had a thrilling time listening to me talk. Bye! Okay, so I just wanted to make some clarifications. First, I just wanted to give simple, kind of more dictionary definitions, just to understand what exactly I was kind of just jumped in and started talking on equations and stuff. I didn't quite explain what it is. So surface gravity, G, is the astronomical term that just means gravitational acceleration, which we know what that means now, which is experience at a surface. Gravitational field, it's just, I like to think of easy, the little kid, magnetic fields, which is the force created by the magnet. Gravitational field is just the force, the space around the space around which the force is created and which experiences the force. So the space that experiences the gravitational force of attraction. Also, like to clarify, F does not exactly, F does equal mg, obviously. But it's not necessarily Newton's second law. It's not really important to know for this concept, just know that it's not true. Also, I kind of talked about test objects, but never explained what they are, and it's kind of good to know for all physics. A test particle is pretty much an idealized model of an object whose physical properties are assumed to be negligible, except for the property being studied. So, it's just an idealized model, pretty much. So thank you for listening to me talk more. It's been great teaching you things.